Hello everyone, I hope you are doing well. Today we are gonna solve a limit problem. The limit looks simple, but it needs two different approaches for us to be able to solve it. The question that we have at hand is the limit of 1 minus cosine theta over theta when theta goes to 0. Okay, so as you might already know, the first step to solve a limit is to substitute the variable with the amount that the variable has to approach to. So basically here, instead of theta, we are gonna substitute 0. So 1 minus cosine of 0 over 0. And we know that cosine of 0 is 1. So 1 minus 1 over 0, which ends up being 0 over 0. 0 over 0 is one of the expressions which are undefined in the limit. A few others are, so one of them is 0 over 0 as we had it here, infinity over infinity, infinity times 0, sine infinity, and cosine infinity. These are all expressions which we say they are undefined. To make these expressions defined, before reaching to the final answer, we can simplify the fraction that they are in, and maybe some terms from the numerator and denominator cancel out, and after that the fraction would become easier, and we might be able to make the limit defined. I'm gonna do that. So we have a very famous expression of 1 minus cosine of 2 theta is 2 sine squared of theta. So we are gonna use this expression, and we are gonna using this expression we are gonna simplify the fraction that we have. So if I continue this limit, I have that the limit of so before being able to use this identity, we have to change it a little bit, because here we don't have 1 minus cosine 2 theta, we have 1 minus cosine of theta. In this expression, I'm gonna divide all the theta parts by 2, and then I will have 1 minus cosine of theta is equal to 2 sine squared of theta over 2. I'm gonna substitute that, so I will have limit of theta going to 0. Instead of 1 minus cosine theta, I'm gonna write 2 sine squared of theta over 2 over theta. Okay. The problem here is that I cannot simplify anything from the numerator and denominator, and that means that it will not become more simplified. Basically, I can still substitute theta with 0, and you will see that again I will get to 0 over 0. So here I will have, if I substitute theta with 0, I will have 2 sine squared of 0 over 0, which is basically 0 over 0, and again the answer is undefined. So what I'm gonna do next is I'm gonna use the limit equivalency equations. I will write them here now. So when theta goes to 0, instead of sine theta, we can say that sine theta becomes equivalent to theta. Cosine theta becomes equivalent to 1, and tan theta becomes equivalent to theta. I'm gonna use the first one, and using that I'm gonna simplify the expression. So I will have the limit of 2 sine of theta over 2, the whole thing squared over theta when theta goes to 0. So in the bracket I have sine of theta over 2. Instead of sine of theta over 2, I can write theta over 2. So basically from this I will have that sine of theta over 2 is equivalent to theta over 2. So that would be the limit of 2 theta over 2 squared over theta when theta goes to 0. And now I'm gonna simplify the expression, so it would be the limit of 2 theta squared over 4 over theta when theta goes to 0. Now we can still simplify the fraction. That would be the limit of 2 theta squared over 4 theta when theta goes to 0, and then I can write it as the limit of theta over 2 when theta goes to 0. We are gonna substitute theta with 0, so it will be 0 over 2, which is simply 0. If you have any comments or if you have any questions regarding this solution, please let me know. I will be more than happy to help you or answer your comments. Have a good day and bye.